Okay. Didn't I just turn that on? All right. I feel a little low. Okay, so 15:4. Any questions about 15:4? Yes. What number? 10? Okay, so it says find the variable, right? Find the value of the variable. So remember that this is outside times the whole equals outside times the whole. So 5 times x plus 5 equals 6 times 12.
Yeah.
Okay. Well, yesterday I saw a lot of students putting 36 there, which is what I told you is easy to do. So, okay. And then you have to be careful about that. 5x plus 25 equals 72. Subtract 25 from both sides. And x equals 9.4. I think this is the same one as the example in the notes, isn't it?
Not the same numbers, I don't think.
Well, that's
But
what
yeah,
I
it's
mean.
the same thing.
Oh, okay.
19.
Did that help? I want to also look at 21. Oh, that's right. And I meant to take 21 off your list. Okay. I did for the rest of the day. I didn't for yours. I'm sorry about that. The problem is in 21 you have to label this. I might have told you guys one thing, but actually you have to label that y and find y. And the way you can do that is, you know that this is a right triangle, right? So one side is 12. Oh, I'm sorry, my book is wrong. My book has a value here. So that's why this one was. Alright, so we're just not even gonna worry about that one. That's what the problem is in your guys' book with this problem. And why I threw it out later is, but, okay? But I apologize for that one. In fact, let me mark on my thing so I don't do this next year. Can I use your pencil? I'll mark off. I'll mark off 21. Okay. Any other questions?
You go with 13.
Yeah. This book sometimes drives me a little crazy. Okay. Okay. When I looked at this problem, I thought that v was a variable. Is that what you did? Okay, because v's a point, right? Did anybody else think I know some of my later in the day classes thought it was a variable too. They're like, how am I supposed to find V? And I'm like, I did the same thing. But it's just simply outside times the whole, right? Equals outside times the whole. So z squared equals 84. Z equals the square root of 84. Okay? All right? Any other questions? What? 18?
I had a thought of
Okay, so let's explain the error. The way you should set this up, of course, is outside times the whole equals outside times the whole. So outside times the whole equals outside times the whole. So this should be x squared equals 40 instead of, they just did, they didn't do outside times the whole. Okay? You see that? Any others? I noticed a problem because of something another student asked me about, and I want to make sure that you guys see this. And it's back in 15.3.
explain everything.
And it's problem number, did I do 14 and 15? None of you guys asked me about 14 and 15, did you? Okay, well, it's really important you understand how this was figured. Okay, so nobody asked me about it, which means y'all can tell me. It wants you to find this angle. I'm going to put a Y there, and that angle. Do you see them? I made them in black, but do you see them? Hello?
What?
It's 14 and 15 on page 811.
Oh, I did those.
Yeah, I did that.
Alright, so nobody asked me about this problem, which means y'all can tell me how to solve it.
I
No.
you want me to try?
Mm-hmm.
So I found the angle of AOB, and that was 124 because it was supplementary to P.
Okay, so this is the central angle, and 56 is the circumscribed angle, and they're supplementary, right? That part was easy. Then what'd you do? What about now? How do I find Y?
Why? Since it's a vertical.
Uh-huh.
Yeah,
Go.
you can, if it's a vertical, you can flip 124 on the other.
Okay, so this is 124 degrees also because those are vertical angles, right? And then what'd you do?
You didn't have to find that, so I don't know.
I don't know if this is right, but like, then you do like the other side of the 124, like, like make it a line. I don't know if that's what you're supposed to do.
Oh, you're saying this here's 56. Is that what you're saying? Yeah, it's true, it is 56, but we don't need it. Yes, Jonathan?
You take 124 and find the other angle like by 180 minus 124 and then divide that by 2.
Why are you dividing that by 2?
Because the other two angles are the same.
How do you know that?
I don't know.
Okay,
I don't
'cause
remember.
you're absolutely right. I just want to know if you knew why you're right.
Well, they look the same.
Okay, which means, remember, that means
Yeah, that
nothing,
means
no.
nothing, but-
Okay, all the angles in a triangle, right? Here's my triangle,
Equal 180.
equal 180, right?
Yeah.
So 180 minus 124 is 56 degrees.
Yeah.
This is an isosceles triangle. Why is an isosceles triangle?
Because two of the angles are the same, which corresponds to the sides. Makes two of the sides make.
But how do I know that those two sides are the same?
It's because
What? I heard it.
Vertical angles.
No. They're radiuses.
No.
FO and OG are radiuses, aren't they? Remember I told you those dang radiuses are hard to pick out, and they shouldn't be, should they? So if those two are congruent, it means these two are congruent. So, hey, if I divide by 2, I get 23 degrees for each one of those.
No.
What?
That's 46.
Oh, you're right. It's 28
Yeah.
degrees.
Yeah.
Okay? But
Yeah, I would have to like confront it. My bad.
But you need to be able to see why that's an isosceles triangle. And I'm pretty sure that you guys are, well, I know you guys are lucky that I talked about this problem because I believe there's one very similar to it on the test. I haven't looked at the test, but if I remember correctly, there's one. And you're very lucky that I happened to notice it on when somebody asked me a question about it this morning before school. Because otherwise I'd never thought about talking to it. So you got to ask me those questions. Okay? That right there is an important piece of knowledge to have, and you guys have skipped right over it. Okay? All right, so 15.5 then?
Oh, that's what we're doing today. Angle relationships in circles.
Okay, so I was gonna have us also draw some things on some circles, but I'm gonna save it for tomorrow in the review. Now, I need to have you do one part of the practice EOC before Friday, okay? So what I'm gonna do, at least one part, okay? I need you to do at least one part of the practice EOC before Friday, the practice window closes. So I had planned on us doing that tomorrow and then the review, 15 minutes. I only wrote down access code for one part. But I think what we'll do is I'm gonna do the circles tomorrow. And when I'm done with this, about the last, at 20 minutes till, or quarter till, I have you get a computer and do the part A of the practice test, okay? And then we'll have it behind us. Since Ms. Stone didn't come today, we'll flip that around, okay? All right, so 15.5. I was trying to decide if I was gonna be here Friday or not, but now I think I've decided I will be. I'm going to a concert tomorrow night.
Beyonce?
I'm kind of excited about
What concert are you going to?
Gary Allen. Huh? He sings country. He's kind of what my kids always called a country rocker. You know, he's kind of but I like him a lot. Do you know? Does everybody know him?
No. Wait, give us a famous song. Give us like the most popular song. Get on my tractor.
I'm thinking.
Hop on my tractor. Ran right past her. If you're going to a concert, you gotta at least sing.
You don't even know his song?
Well, I can sing them. I mean, but I can't tell you that. Like, I'll get them wrong. Like, there's one about watching the airplanes take off, And,
No,
That's
not
what
kind of
you-
country
that's
song
what
that.
you-
oh, all my favorite are watching airplanes. Life Ain't Always Beautiful.
I thought country songs were supposed to
I
be
love
like
Smoke
farms
Rings in
and
the
tractors
dark.
and pickup trucks and country ladies, but no, airplanes, really? Hey, help my Shrek.
It would be you. Anyway. Okay, 15.5.
And country.
What? You said the song that bad? Bro, I got lost. Never mind.
Okay, so what are relationships between angles formed by lines that intersect a circle? Okay, we already know chords, right? And piece times piece equals piece times piece, right? So if we look on page 830, there's intersecting chords angle measure theorem, okay? So in this lesson, we are going to talk about, I want to recap, oops, that if I have a central angle, the intercepted arc is the same, right? If I have an inscribed angle, it is half of the intercepted arc. Okay, so I'm talking, I got phone, oh my gosh. Really?
Well, this is awkward.
Do you guys like it when teachers collect phones at the beginning of class? Do you like those classes? I wouldn't either, which is why I don't do it. I think every other math teacher in this building does it, by the way. Miss William does, Mr. Brown does, Mr. Thomas does, okay? All of them, but me. I'm pretty sure I'm the only math teacher in here that does not make you put your phone in a bin. But do you see why they do? Does it make me mad? A little bit. A little bit. Okay. Just gotta bring myself back down.
I didn't know how to play that situation.
Now, if I'm not interrupting anything going on in anybody's life, I would like to proceed. Is that all right, boys? Can I? We ready?
Yes, ma'am.
Shake your head, yes. There really is no other answer. So, all right. So, we know if the angle, the vertex of the angle is on the circle, okay? The vertex of the angle is on the circle. This is half of this, okay? We know if the vertex of the angle is in the center of the circle, they're equal. Now, this is not on the circle. It's not the center of the circle, okay? It's just in the circle. So, what this is saying is the measure of this angle is half. Oops.
Oh, squiggle.
Half
Yes.
of the two arcs. Okay, so I'm going to write an example here. I'm going to put this as 80. I'm going to put this as 40. So the measure of angle 1 equals half of 80 plus 40, which is 60. So the measure of angle 1 is 60 degrees, okay? Now, who can tell me where you've seen this before? And I'm gonna write it, if you can't get it, I'm gonna write it a little differently and I think you'll pick it up. Anybody know where you've seen something like that kind of equation before? Not in here, just in a math class?
Wait. No, never mind.
Okay, I'm gonna write it a little differently.
Oh. Okay. I thought about that, but I said, nah, that's not it.
What? Did I hear it? No?
Like, is that the distance or
Huh?
something? Is that how you find like the midpoint?
Okay, average. Exactly, yes. That's the average, right? So when that angle is just somewhere in the circle somewhere, it's the average, it's the middle of the two arcs that it's intersected, okay? And that works for all of these. If I was trying to find this angle, I would use this one and this one, right? Okay? It works for all of them. So let's look at a real example. On the bottom of page 831, it says find the measure of MPK. So I'm going to put an X right there. Okay, so X is going to equal 1/2 of 61 plus 111. So 1/2 of 172. Make sure y'all keeping track of my math. And then, what, 86? Is that right?
Yeah.
That is very correct.
Okay. Now, number 5. It says find the measure of arc PR. So I'm going to put my X out here. Now the formula doesn't change, right? It's the angle equals 1/2 the sum of the two arcs. So I've got 58 equals 1/2 of 82 plus X. Do you see that we're just putting it in a different place? Okay? So when I'm solving for X, what's the easiest thing to do right here? First? Yeah. Multiply by 2. You could distribute 1/2. You could use distributive property and do 82 divided by 2 and then 1/2 X. But it's a lot easier just to go ahead and multiply both sides of that equation by 2. So if I multiply both sides by 2, do I get 1/16?
Yeah.
I'm multiplying both sides by 2. And 2 times 1/2 is just 1. Do you guys see why that gets rid of the 2? Let me write this. Because this is really, I could rewrite this like this, right? Okay? It could be rewritten like that. But does that help you see why multiplying each side by 2 gets rid of that 2? So I get, what I said was, 1/16 equals 82 plus X. Subtract 82 from both sides. And I get 434. Okay? All right, ready? On top of the next page, it says secant tangent interior angle. Do you see this is, where's the vertex on that circle? Oh, I've said it. The vertex is on the circle, right? So what do I know about the measure of this angle?
It's half of the side.
It's half. Remember I told you they can look a little strange, but it's still, if the vertex is on the circle, the angle is 1/2 the measure of the intercepted arc, okay?
Understood.
So let's look at number 6.
Go brain this, yeah.
Number 6 wants us. Number 6 wants us to find arc PN. Okay, so PN is from here to here. Now, do you see that 61 goes right here in this angle? So if that angle is 61, what is arc PN?
122.
122. Okay, those are the hard ones to see. Yes.
So you just like multiply like that angle by 2 and the
Yes.
arc. Okay.
Yeah, when it's on,
On the vertex.
is half of the intercepted arc. So you're either dividing the arc by 2
Or you're multiplying.
or you're multiplying the angle by 2.
Okay.
Wait, do you think there's a brain pop for geometry?
A what?
Brain pop, that website with the robot and that guy named
I don't
Tim?
know what that.
You don't know what brain pop is?
Oh, my entire my childhood, you do not know.
You're a teacher, you don't know what it is?
Well, no, but she's a high school teacher, though. That's different.
And my youngest child is 20 years old.
That's how I look.
So how long ago did it come out?
It came out a while ago.
Okay, so now what's MNP? Yeah, MNP. So I'm gonna put Y here. Alright, so if this arc from here to here is 238, how much is Y?
119.
119. Okay? It's half of that arc.
Go absolutely bonkers.
You're absolutely
I love that.
Okay.
He's about to ask Aaron for his game.
His face is getting red.
What's your protein bar?
Now, can you wait? Alright, so this is the. Alright, so the next part is outside the circle. Okay? And when it's outside the circle, we're subtracting. Okay, so I'm going to write all these over here though. So we have the vertex has a couple of possibilities. It can be at the center, right? And we know those two are the same. It can be on the circle, and it's half. It can be somewhere in the circle, and it's 1/2 of the arcs added together. And this last one, what you see at the top here, is if it's outside the circle. If it's outside the circle, it's 1/2, and you subtract these arcs.
Wait, can you move it down a little bit? Thank you.
Okay? And I kind of squished this. Let me rewrite it. Okay, so do you see the only thing you have to remember, the central angle is the same. On the circle is 1/2. Somewhere in the circle, I'm going to add them together and divide by 2. And outside the circle, I'm going to subtract them and divide by 2. Okay, yes?
Okay, so this is dumb, but like, how do you know which one's like X and Y? How can you subtract
You're always going to subtract the bigger one.
the bigger one?
Yeah, so let's do one.
8.
And you can go now. You need to go.
8. I think-
So, if we look here at A, okay, the angle equals 1/2 of the difference of the two arcs, okay? So, if I'm multiplying each side by 2, and then I subtract 83, oops, what is it, 33?
Yeah.
Equals negative x, so 33,
How'd you get negative?
what?
I mean, how'd you get negative 33?
Because
Oh,
X
50 minus F.
Yes. Okay? So if you look at the next one, do I know? I can only have one variable, right?
Correct.
So I must know what this is.
Yes, you did.
How?
238 minus 360 minus 238.
360 minus 238 gives me what? 120. 122?
Yeah, he's right.
I'm faster than a calculator.
Is that right? That's not right.
Dang it. 360 minus 238 is 122.
Yeah,
You don't
it
calculate.
Is it 122?
Yeah.
Because 1
Okay.
is to 3.
Oh, I was thinking 80, not 60. Okay, so x equals 1/2,
Where'd you get the 120?
238, okay, voice, minus 122, and then you just, x equals 1/2, 6, what, 116? Is that right? Yeah. And so x equals 58. Okay?
Yes.
So you got the 122 from subtracting 360.
The whole circle is 360 degrees, right? And that 238 is all of this. Okay?
So like if you don't know what, or if X is the angle, you can always just do 360 minus whatever arc it gives you.
What now?
Okay, so like if you don't know, like if X is the angle and it only gives you like that arc, you can always just do 360 minus.
Yes. It's gonna have to give you some way of finding that other arc. So there might be a couple of arcs in here. You know, it might give you a couple of measurements that you have to subtract from 360. Okay? All right, if you look at 834, it gives you, right? That's a neat little thing that it shows you on the circle, in the circle, and outside the circle, right?
Oh, yes, it does.
So it's a good little summary about this section. So flip to the last page. 835.
What page?
835. It says to find CD.
Or just go to the CDs.
And FD. Okay, so we gotta find FD first. But I wanna make sure that when I do a picture like this that you can see, right? So here's my angle of 50 degrees. Okay, and it's outside the circle, right? I'm gonna put an X right here. So 50 is going to equal 1/2 of 150 minus X. And it's minus because it's outside. Now to me, it's just always made sense that you're doing a minus sign when it's outside and you're doing the plus sign when it's inside. I don't, that might just because I'm a math person, I don't know, but to me it just made sense. So if I do this, I get 100 equals 150 minus X. Subtract 150 from both sides. And I get negative 50 equals negative X. Or 50 equals X. So that one happens to be the same as the angle, doesn't it? It's not always true. Okay? Now it says find CD. I'm going to write a Y here. How am I going to find CD?
50 plus 150 plus 64.
360 minus
Or that.
60. Well, you added them all together, and then we'll subtract. Minus 150 minus 50 will give me CD, right?
96. I believe.
Is that what it is? 96?
Yes. Yeah, I think.
Yes, 96.
Bro, I'm crazy.
Okay. All right, take a second and see if you can find KN here at the bottom. KN from here to here.
Okay.
Okay, so take a second and see if you can do that.
Okay.
For this one,
Okay.
ambition would start out trying to find the easy.
Mm-hmm. Yes.
What's 79 times 2? 2.
You're going to look at a different part of the circle.
Oh, what's that? What does it have?
79 to.
I know, but to find KN, find PN first.
This is not in the middle. What's 79 times 2?
No, the angle. So 79 equals 1/2 48 plus X. Or Y. Because the angle. Look, the angle equals 1/2 plus X. That's the angle.
Okay.
think about what PN is first, because there's nothing you can do to find KN right away. So if I look at PN, I'm going to label that Y. So remember, the angle is always equal, and it's inside, so it's a sum. It's adding them. So if I multiply by 2, I get 158. If I subtract 48, I get what, 110?
Yep, you heard.
And then I have 360 minus 48 minus 86 minus 110 will give me what?
116.
116? And there you have it. Well, do you see how to do these? I want you to do 3 through 19 for homework.
We're doing what
3 through 19. Oh yeah, go ahead and ask me what page.
836. Jinx.
Hey, Sean, are you listening 13 or 19?
8 through 19. 3 through
No,
3 through 19 pages. It's
13,
3
isn't it?
3
No, 3 through 19.
No, you're
What
going
did I say?
3 through 19. I don't know how
3 through 19.
I don't know how to work off. This is supposed to like hold it and it goes out. It's like it's